Hi there, welcome to my presentation. I'm Orion, and I did my presentation on this paper here, Cell Trend, a paper by Zhicheng Liu and John Stasko. Alright, let's dive in. So, Cell Trend, at its core, it is about airline efficiency. It's about making sure that travel agency companies don't have cell failures. I'll describe what that is in a minute. But in short, airline efficiency, presentation by Orion Houndstrup. Welcome. All right, so you got a customer. Oh, I don't have a mouse when I do that. Forgive me. We'll do it this way. You've got a customer who's trying to make a purchase of an airline ticket to go someplace. In theory, when I do this myself, I tend to go directly from the customer to the plane ride. I'm very easygoing. However, you always have at least a couple middlemen along the way. You're going to be buying your ticket from some kind of an airline company, in this case Southwest Airlines, and a lot of folks who sort of do it right use a travel agent. Now, in the old days, that would have been a person in person, like this woman here. More realistically, in the modern world, you use someplace like Expedia.com or Kayak.com, and so you've got your virtual travel agent. Cell Trend is a piece of technology used by none of the above. They're used by Travelport. So Cell Trend is a new piece of technology that the two gentlemen who wrote this paper were commissioned to make for a company called Travelport. Travelport is an in-between company that works between the travel agents and the airline companies. They're what's called a flight reservation coordinator, and their job is the following. Sometimes when the customer goes to purchase their airline ticket, as you can see by these humorous little clip arts over here, things go wrong. What specifically goes wrong is sometimes, for instance, they'll be buying a plane ride that has, let's say, a couple layovers, and at the moment that they press the purchasing button, one of them sold out. Between the time that they were beginning, to look at the various different flights and what's going on, to the actual moment that they clicked buy and they went through with their credit card transaction. Sometimes there's glitches in the software, things go wrong. Sometimes a plane was canceled, sometimes one of the planes is delayed. Sometimes that plane ride wasn't even available in the first place, and it shouldn't have been available for sale. But remember that the person is either interacting with the travel agent like Expedia, or perhaps directly on the airline company website, and the glitch might have occurred here, it might have occurred here, might have even occurred here. Either way, this is called a cell failure, and sadly, they're pretty common. It's a source of lost revenue for Travelport. And so their job was to see if they could make this whole thing, hang on, I'm sorry, it's probably actually a loss of sale revenue for the airline company and the travel agent. So that's what Travelport does. Travelport's goal is to make this whole process more efficient, more streamlined, and have less failures. So the trouble with this job is that there's a couple of different things going on. Tons of customers are buying flights all the time. Millions of people. Sorry for that in this. I'm at a Whole Foods. Sorry for the sound in the background. So millions of people are buying flights all the time, and it's constantly streaming in, so the flow of traffic never ends. You've got intensely large databases, and the databases are both time sensitive, they have a timestamp of hour and day associated, as well as categorical data. Let me see if I can get you my face while we're having this little conversation. So the combination of having very intensely multivariate data, you've got what airport you're leaving from, what airport you're arriving to, you've got first class, business class, you've got all kinds of various data points. Busy time of year like Christmas time or not. And the trouble is that you're combining a ton of data with multivariate data, along with it being time sensitive, and then the last major important part is its categorical data. Things like, for instance, the name of the airport. It means that a lot of traditional mathematical models, like various types of calculus things that would be able to find optimization points, don't work because those need smooth data, and instead we have discrete data, this categorical data. So the old way of doing this was to look directly at the Excel sheets and just get completely lost. It's way too much data for one person to just drift through. It's as you can see by this funny little image here, just about impossible. So these two gentlemen, Zhicheng Liu and John Stasko, as recorded in the paper that I read this week, they invented this program here. It's called Cell Trend. Cell Trend is an info visualization program that basically allows the workers at Travelport to way more quickly and more efficiently sift through all this data and find meaningful patterns. Let me tell you a little about how it works. So on the bottom here, you've got your printout of dates and of hours, so you can sift through the data by either which date you'd like or by hourly. And basically what you're looking for is which flights, and by the way, a lot of the data is based on rows. Lots and lots of different types of categories this can be broken down into and sifted through, filtered through. It's a very intensive app. So what you see here is that, let's say this blue rectangle corresponds to a particular airline and a particular kind of sale from one airport to another airport. Let's just, for the sake of conversation, say this is San Francisco to Boston. So let's say that particular airline sells a lot of tickets. That's why it's a big, nice, chunky rectangle. If this is Anchorage to, I don't know, how about Rochester, New York? That's a very small set of data, and so the size of the rectangle corresponds to how many raw sales there were. So blue means that there were less sell fails than usual. Orange means that, sorry, not blue, it's purple. Purple means that everything went smoothly. There's less failures than usual. Orange means there's more fails than usual. So one of the problems with using the gradient from blue to orange is if you're just looking at more or less fails, well, that's going to be heavily related to and correlated with, well, how many sales in total were there. You know, busy time of year like Christmas time, everyone's flying everywhere. Honestly, you're always going to have more fails because you have more people trying to purchase tickets. So that's not the best way. So in short, this app lets you sort through comparing how many sales there were this time with historically how many sell fails were expected. So orange means worse than expected and purple means better than expected. All right, you've got, of course, as you can see, a lot of stuff going on here. The most important thing to note is that this InfoViz is interactive. If you click on one of these rectangles, over here it prints out a lot more info, and you can sift deeper and deeper and deeper into it. So I know it looks a little overwhelming, but you can actually really dive in there and learn a lot by clicking on any one of these rectangles. All right, let's take a look at how to analyze this InfoViz. So CellTrend analyzes lots of airplane data. It lets you find underlying trends and patterns. This is sort of the how and the why. Most notably, it is a squarified tree map. That's what this is. And the reason it's particularly an innovation is its use of the tree map to address categorical data. As you can, of course, tell by just glancing at this thing, channels involved include color, size, X and Y position, and interactivity. Probably there's more going on there that I've forgotten about. But those are the first ones that come to mind for me. Most notably, the main thing that makes this a wild improvement over the old way of doing it is the interactivity. The interactivity of this thing lets you really go quick and efficiently. And it's pretty impressive, frankly, what they came up with. I think it's kind of amazing. All right, big question. So all this amazing stuff that these two guys did, does it work? Well, according to them, and take it with a grain of salt, they're the ones who designed it and they're the ones telling us how well it worked. They would say that they employed it in the late 2000s, and they suggest that this reduced the investigation time to find what's going wrong with these cell failures by greater than 90%. That's pretty wild, frankly. I'm not sure I believe them. That's what they say. 90% improvement is vast. Frankly, double time is usually already an incredible improvement. 90% seems a little much, but according to them, the results were wild improvements over the base case. Alright, so let's take a little analysis of the pros and cons of this thing. Let's say it works as well as they say. Let's just cut them the benefit of the doubt and say that it improves efficiency by 90%. So the first thing you've got for strength is speed. I mean, gosh, if it's making the workers be able to get 10 times as much work done, that's incredible. Their use of color as their primary channel of good and bad, as compared to, let's say, size or shape or other types of techniques, movement, let's say, I think it really pops for the human eye. It really lets orange stand out and be obvious, and it really makes purple, likewise really stand out. It really, you dramatically see this one and this one and this one, and all the way down to even these little points. So you really can fairly well and quickly tell what's going on. Like even in this little chunk here, boom, you can just see which points were bad. So the use of color, I think, is excellent. The other thing that's an incredible strength about it is they came up with this wild new tree map interactive application for this specific purpose, but frankly, it seems to have very far-reaching applications. You could use it for all other kinds of industries that have multivariate, time-sensitive categorical data. It's pretty impressive and interesting, and I'm sure that basically when they designed it, they must have been pretty thrilled. They came up with this new, crazy, new, wild thing that might have much larger ramifications than just trying to help Travelport. Alright, limitations. My first thought is anytime a company tells me that they've improved worker efficiency by 90%, all that to my ears sounds like is you're about to fire 90% of the staff. Worst case scenario, let's say the application doesn't work as well as these guys are saying. The executives are going to say, ooh, 90% efficiency, and just fire 90% of the staff, and then you're going to have one overworked, caffeinated person trying to desperately use this thing that they probably even weren't very well trained on to do 10 times more work than they used to for probably the same pay. It could be an absolute bloody nightmare. I'm intensely skeptical that any company would use any piece of technology for any moral reason at all. I just don't buy it. So, to me, honestly, I'm not even sure that we, the workers at this place, want a more efficient piece of technology because we're all going to lose our jobs. More importantly, let's say that the company isn't an evil, scummy corporation. Leo and Stasco directly say it's not clear to us whether the analysts will be overwhelmed by the rich information. Genuinely, this tool seems like it really would require some pretty intense training. The workers have to really have the time and the onboarding necessary for them to really understand how to utilize this to get that 90% efficiency increase. And if I've worked a lot of jobs, I highly doubt that the company is really qualified to get ready to make use of this piece of amazing technology. So I think it might just simply sound cool to the executives while potentially not even really helping much in the real world. So, last thought on the matter. 16 years have passed since it was implemented. Just me? I'm really curious how it went. What was the effect upon the implementation of the new technology? Was it actually used for ill, as I'm so worried about? Because, gosh, it really sounds like this poor piece of technology. In the end, I'm sure these guys are smiling. I think that all that happened is a lot of people got fired when this came out. That's what it sounds like to me. Did that happen? Did it not happen? What problems were found with the technology? What improvements happened later? Because this is the first draft. I'm very curious what, version 5.2 looked like. And lastly, in the modern world, as AI is taking over everything, I'm very curious how more modernized versions of this piece of technology look like. What does the current actual version of this look like? And frankly, I'm not even sure that humans are going to be involved at all. I'm very curious how the modern mechanized super search for efficiency interacted with stuff like this. Alright, that is my presentation. Thank you so much, and frankly, it's a really interesting article. I enjoyed it, and it's always interesting learning about progress of technology from this stuff to, honestly, a much, much, much more advanced, better system. Thank you so much for the paper. I had a good time reading it. Alright, be well and take care.